Hello guys, today we are going to discuss about Venn diagram. A Venn diagram, which is called primary diagram or set diagram or logic diagram, is a diagram that shows all possible logical relations between a finite collections of different sets or elements or items. So to explain it in a simple way, if there are more than two or three items and they are somehow related with each other, even not related with each other, we can show um, them diagrammatically and conclude some logic out of them or infer some deduct some logic out of them. The element or items can be shown as a region inside a closed curve. You can show it as a circle or a rectangle, does not matter. A Venn diagram consists of multiple overlapping closed curves, usually circles, each representing a set. And we will see how in nature there are several kinds of Venn diagrams we can conclude or deduct based on things you choose. In one of this example, you can see we have three entity or three elements, city, state, and country. So if you see, the country is the superset. Inside the country, we have several states, and inside a state, we can have several cities. So city stays inside the state, and state resides inside the country. So this is one type of relationship between city, state, and country. In the second set, we can see there are three entities or three elements: animal, dogs, and trees. So how we can depict them? A dog is an animal. So dog belong to animal kingdom. Whereas tree is not an animal. So the tree stays outside animal kingdom. So this is another type of set relationship. There is a third type where three entities are interconnected with each other or somehow related with each other. I can give you an example. In a family, suppose father, mother, and child. There are certain things that father only uses. So this is the thing only father only uses, and there are certain things mother only uses, and there are certain things child uses, and there are common things where both father, mother, and child uses. To give an example, child suppose going to school, so she uses a school bag, and mother going to work or cooking, she uses cooking stuff, and father going to office by his car, that belongs to only father or he uses. But there are few things which is father and mother they uses but child does not use, and this area is everybody uses. Give an example, bathroom. Everybody uses bathroom in a family, the same bathroom, or any a mirror. Everybody uses same mirror. So this is another example. The fourth example is, suppose we take mango and apple. Even if they come under a superset fruits group, they are in no way related to each other, so they stay separate. Let's go to the another example. Same way, sun, moon, planet, they are not interrelated with each other. They are, but here we cannot, if there is no direct relationship between each other, they can stay separate. And there is another type of relationship between three entities: fruit, oranges, and juice. So juice can be deducted from or made from any of these fruits and also from oranges. And if there are other fruits, suppose you can have mango here, and so mango is a fruit also, you can get juice from mango. And lychee, you can get juice from lychee, and juice is also fruit. So this is another type of relationship. And there is another type of relationship, type 7 relationship, where um, there are three entity interconnected with each other, whereas only one interacts with both entity, and the two entity they don't interact with each other. Just to give an example, mother, colleagues, and relatives. So there is a person who can have some colleagues in his office, and some relatives he has. So he has a commonality between relatives and between colleagues, but colleagues and relatives are no way interconnected to each other. So there are like several kind of other relationships can exist. Once you know how you can relate it, it becomes easy. So this Venn diagram we use for syllogism kind of questions in the banking exam, and in syllogism kind of questions only four types of proposition is used to find out the logical conclusion of any problems. In one of them, the first one is all x are y. If a problem set mentions all x are y, then you have to make a diagram like this, that all x inside a superset y and some x's are y. Then in that way, in that sense, some part of y is x. So this is common to x and y. And no part, no x's are y. So this is the part where only x but not y. And some x's are not y, the same thing. So maybe this part is some part of the x's, it's not belong to y, but it's not the whole x's, whole x part. So you have to figure out, or you have to find out how you deduct or how you made a graph and find a logical conclusion to it. Once you practice few times, it becomes uh, imperative, or it becomes clear to know what is the answer. So here is a Venn diagram that is shown to show the different relationship between A and B. In A and B, this portion which belongs to common A and B called A intersection B, and when you add both A and B, it's called A union B. So you will see there are a few questions that will come in the exam where they will ask to find out A union B or A intersection B. You might also be getting some questions like, in a class there are some students takes maths, some students take English, so some students take both math and English. So how many people are take only math, how many to takes people are take only English, how many people are take math but not English? So here the same thing. So if this is math, this is English, and here students are both math and English, so this portion A union B prime will be people or students taking only math, and this one, the other side, A prime intersection B, students only taking English. We are going to do some questions based on the Venn diagram. Which of the following diagram correctly represents tiger, lions, and animals? So let's see. As we have discussed before, tiger and lions are two animals. They are not related to any, in each other, but they live inside the animal kingdom. They belong to the animal kingdom. So in this is probably not the right answer, because this is different that we discussed. This is also not the right answer. This is also not the right answer. So this is the right answer, where this is the animal kingdom, and inside the animal kingdom there are two animals, tiger or lion, and they are not related with each other. So the answer is A. In the next one, let's find out in syllogism we have to use Venn diagram. It gives a statement and you have to deduce the conclusion, which conclusion are true. Some shows are plays, some plays are movies, no movie is a theater. So if we see some shows are play, so here is the show. Some plays are movies. So this is plays and this is movies. No movie is a theater. So theater is completely outside. So what is the conclusion can be drawn? The conclusion one says all movies are plays. But if you see, it says some plays are movie, So if some plays are movie, then it cannot be like all plays are movie, because there might be some plays which are not movies. So that conclusion is not true. So only conclusion one is true is false. And next conclusion is some shows are definitely not theaters. So in this, we don't know, because theater lives outside. There is absolutely no resemblance or no relationship between either movie or plays. So we cannot deduct anything, or we cannot conclude anything on whether the relationship between show and theater exists. So this choice is not true. Both conclusion 1 and 2 are true. This also is not true. Either conclusion 1 or 2 is true. So in this case also, we cannot say this one or this one is true. Neither conclusion 1 or no 2 is true. So from here, we can find the is most close answer, because from this we cannot conclude which one is the true. So the option is answer is A. Let's go to the third question. In a class, 70 students like to play basketball, 80 like to play cricket, 30 students like to play on both basketball and cricket. How many students like to play basketball or cricket or both? So in this case, we have to find out A union B. So A union B, as we have seen in our previous picture, suppose 70 students like to play basketball and 80 students like to play cricket and 30 students like to play both basketball and cricket. That means this portion is 30. So when we are taking 30, so this 30 portion has been added twice, here one time, and then when we are taking this one is also adding one time. So we are adding actually 32 times. So in this case, A union B is always A plus B minus A intersect B. That will give you A union B, or the students who play both basketball or cricket. So in this case, we can find out the result 70 plus 80 minus 30. So the answer is 120. Next goes to the another question. How many numbers are there between 1 and 100 that are not divisible by 2, 3 or 5? Which is a little bit tricky questions. Let's create a Venn diagram to understand in a better way. So consider these are the numbers divisible by 2. These are numbers divisible by 3, and these are the numbers divisible by 5. As we know, any number from 1 to 100, 2, 4, 6, 8, 10, 12, 14 up to 100 are how many? Like 100 divided by 250. So total number that can be divided from 1 to 100 by 2 is 50. And similarly, if you go 3 into 1, 3, 3 into 2, 6, up to 3 into 33, 99, there are 33 numbers which can be divided by 3 from 1 to 100. And for 5, 100 by 5 is 20. So there are 20 numbers that can be divided by 5 from 1 to 100 when we take from 1 to 100. So now we have to find out how many of the numbers which are divided by both 2 and 3. So this is the place who the number which are divided by 2, 3 and 5. We have to find out first this place. So anything divisible by 2, 3, 5 can be 2 into 3 into 5. So that comes 30. Just like to give another example, if I ask you which are the numbers which will be divisible by both 2 and 3, so for the minimum multiple has to be 6. So that means 6 is divided by 2 and 3. Then 12 is divided by 2 and 3. Then 18 is divided by 2 and 3. So it's a multiple of 6. Similarly, how many multiples of 30 are there in 100? 30, 60 and 90. So we put 3 here. Similarly, let's find out how many numbers will be divided by both 2 and 3. So from 1 to 100, any number will be divided by 2 and 3 will be 6. So 100 divided by 6 is 16. So there are 16 numbers which can be divided by both 2 and 3, and we already have 3, this 3 number out of 16 number, because this also we have taken into account. So this area will be 30. And then similarly we can find out between 3 and 5, that is 15. So 100 by 15 comes out 6. So there are 6 number present from 1 to 100 which can be divided by both 3 and 5. But out of 6 we have already as considered 3 here, because these are 3 numbers which are divisible by 3, 2 and 5. So out of 6, 3 is gone, so 3 here. Similarly between 2 and 5 there are 10. 100 divided by 10, 10 numbers. So out of 10 we have taken out already 3, so 7. Now we know this is 50, this is 20 and this is 33. So we can find out the rest, this portion, this portion and this portion. So if we add 30, 13, 3 plus 7, that comes out 23. So 50 minus 23 is 27. Similarly, the total is 33. Here 13 plus 3 plus 3 comes out 19. 33 minus 19 is 14. And out of 20 we already have 7, 3, 3, which is 13. So this portion come out as 7. So total comes out 27 plus 13 plus 14 plus 7 plus 7 plus 3 plus 3, and total 76. So 76 numbers are there which can be divisible by either 2, 3 or 5. So how many will not be divisible by 2, 3, 5? 100 minus 76, 24. So the answer is D. Thank you.